is the presentation of the Soil Profiler, a program developed for class Advanced GIS Programming for Engineers taught by Dr. Dan Ames at the Civil Engineering Departments of Brigham Young University. The program was developed by Carlos Osorio Murillo and Fidel, and we are glad to present our results.
Gray skies are bound to clear up. Put on a happy face. Oh yeah.
The instructions were to create a standalone desktop GIS-enabled application that allows the user to draw a soil cross-section line or polyline at any location within the software study area, and compute and graph the longitudinal soil profile along the drawn line. Soil column data was retrieved from the web and interpolated using third-party software according to the instructions before being brought into our software. Soils are difficult to see because they are underneath the surface, and there are many ways to interpret what's below the surface, and this program is one of those tools that allows you to see what is in the soil, what are the structures. The general characteristics of the soil profiler are: the application is able to do interpolation automatically between boreholes. It has a web map-based plugin. It has user controls to interpolate data in the application without the need of third-party software. It is highly visual, so the maps, profiles, 3D views dominate most of the visible screen, and it is very user-friendly. What can be done with the soil profiler? First, it can draw a longitudinal soil profile based on data input from boreholes and wells. It can draw a soil column view with color codes that match the colors in the soil profile view. And it can construct a 3D view of the soil layers. The application is designed to process the borehole information, and it generates a triangle irregular network to join profiles. This network is used for the configuration of the layers of profiles. And also it interpolates between boreholes in order to represent the longitudinal profile. How was this program made? We created a project in Codeplex to allow changes and modifications always available to both team members. The project name is Soil Profiler, and Codeplex is a Microsoft free open source project hosting site. And you can create projects to share with the world, collaborate with others on the projects, and download open source software. We created our Codeplex account and a profile for the project and selected a license. Codeplex provides a rich set of functionality for hosted projects, including Team, Foundations, Server, Git, or Mercurial for project source control, project contributor forks or patches, project release, downloads, discussion forums and mailing lists, wiki and documentation pages, and bug and feature request tracker, as well as project usage statistics and other. The program is based in C#, the Spatial and Visual Studio version 2010. We added windows, form controls, menu, and those spatial controls, map legends, and added code to menu items to interact with the map. The application supports and stores information in SQLite, and we added the forms again to make the menu items that we needed.
Well, that was different. Yep, lousy, but different.
User-friendly, and we can see the downloads of the Soil Profiler to attest of this. What type of data input is required? Well, we need soil data. It can be retrieved from the web, and there are many sources. One of the good sources of data is the National Resources Conservation Service, from where you can export data from the soil data marts in the form of zip files. We review a lot of this data, which is in the what they call the Surgo 2.2 formats, in tables and job files and text files that are provided within this soil data. But we decided to use data that was a little bit simpler, and we used an example of borehole and whale soil profile data found in the Aquaveo web page, from where we then loaded this data. This is from the Arc Hydro Learning Center for ArcHydro groundwater, which is a geodatabase designed for representing groundwater datasets within ArcGIS. And the application uses 3 files, which are called wells, borehole, and unit. And soils are quite complicated, as you can see in this map of soils for Utah. The data we're using is much simpler. It has well features as one of the files, borehole features as a second, and the third one is hydrologic units. And the data is in this format. For the wells features, we have the hydro ID, the type, and the coordinates x, y. For the borehole features, we have uh, more columns. We have the well ID, we have the reference elevation, we have the depth, and we also have the top elevation and the bottom elevation of each layer, and we have the units, which is feet in this case, and the hydrogeological units ID. Finally, the third file has the hydrologic units, and this is a shorter file, or at least it has less columns. It has an ID, it has a code which stands for the hydrogeologic units, and the description that is later used to display in the legend that we have created. We have user controls like project view, data, and tools. We have display wells, select profiles, triangulation, select triangle, and draw transect. And we have other common user control tools like zoom in, zoom out, zoom to extend, preview span, select and deselect, identify. And what does the user view? Well, this is what the user sees, mainly graphical displays, and we will give you a demonstration in a short. We are ready to start, and we hope you watch the rest of this video here.
Have you seen the scene? Even when you know what it is, you don't know what it is.
Well, Carlos and I are glad to present to our big audience what we would like to see now.
Phenomena. Phenomena. Phenomena.
Hi, this is Carlos Osorio. I'm going to present the application. The application has one menu, a start menu to open a new project or create a new project. The project is stored in a SQLite database. I'm going to open one project that we have. This project contains the information of the boreholes that can be imported using these 3 options. The first is import the wells. That information is stored in the database. We can import the soil units, and we can import the boreholes. After you import the information, it displays directly from the database the boreholes, and the user can select each borehole that is selected. It creates the vertical reference of that selected profiles. In this case, you can see the different units of the selected profile. You can select the many profile that you wish. Okay, the difference with the other projects, this project is calculated automatically the interpolation between each boreholes. Not only one value, is using all the different depths of each profile to create this grid. We can select one of these triangles. The triangles are linked using a small application that realize which walls are joined and make the link between each wall. It's very useful. You can check how is the behavior of uh, the area between boreholes, and you can see how are connected the boreholes. Also, you can create the transect study area, and is making the interpolation uh, according with the each triangle is getting the information of each layer. The information can be observed using a 3D view. This 3D view allow you to see the different combination, how is the information of the each borehole, and how they are connected, but in a 3D view. You want to see how it's changing the different layers. It's very simple. This is using another library that is called OpenTK, and this is also an open source library similar to DotSpash. Thank you. I'm going to explain the source code of this application. Okay, this application use different uh, classes. The main class is program, that is called the application, and the main form is profile. This profile get the uh, has the configuration to obtain the plugins from DotSpatcher, and made it establish how is the beginning of the buttons. The enable menu allow you the user to configure the first stage of each button. Okay, there are some functions to capture the mouse. The first one is the click. In this case, it's cleaning the walls. Walls is a global variable of different dot spatial features. For example, points are represented by walls. Polygons are the profiles, but it's in the 2D view, 3D view of each profile. Um, the triangulation is stored in a class that is called configurer triangulation. There are auxiliary feature sets for each mm, layer, and there are another important functions. The first one is when the mouse is mouse up, automatically can be executed two functions. The first one is to get the profile, and the second one is to draw the profile but that are contained in each triangle. This is the function to draw the triangles, and also the links between each profile is only getting information for each borehole. He is making the configuration of the colors of the profile that is shown in the right side of the application. Here is also auxiliary functions to make that process, and each profile contains information that was obtained from that text file. There are one function to establish the attributes of each layer. Please create profile layer. There are one function to manage the menu. There are one function to add the rasters. We can store the information of the new project, establish the name of the project, and everything is stored in one database. This class database manager is from the application is creating a small text database SQLite that is only one file, and we can open also one project. In this case, we are getting the information of the project that's contained in this database. There we have walls. We can import the walls, draw the walls. Is only creating a feature set of points, but it's reading the information of the database that is contained. Select all the walls that are contained in that project. Here in this item is stored information of each well. It's creating one class that is called columns. That columns class contain all the information of the well, and in each class columns there are a new class that is layer column. Layer column is a very simple class in which it contains the information that we get the database. We can remove the layers. We can check if one layer is available. Uh, it is check there are another function to make to pass a boolean value, and we can import the soil units, the boreholes. There are another function that is important, that is to draw the wells. This is making all the options that we have talked about previously. And here is the main function to calculate the triangulation. It's using a class that is called the now triangulation. The code is from internet. And internally is created the triangulation and is associated with each vertex. In this case, we can call we realize which is the points that are contained in each triangle. And configure triangulation make the triangulation between the different layers of each triangle. We can draw the clay. We can draw the longitudinal profile that is in a new class. This class manage all the features for drawing and also make the interpolation of each triangle. Here in the bottom, we can calculate the information of each triangle according with the position that was established. Okay, we can draw the triangle here. Start drawing the profile. Execute this small option to visualize the profile. And here we are calling the form that is managing the 3D view. The 3D view is managed by a new application. This is OpenTK library. This is an OpenGL library. We can do it very easy. Thank you very much.